In Topic 7, we will be looking at linear equations and their graphs. When you have completed this topic, you will be able to graph a line using a variety of methods, determine the equation of a line using characteristics of the line, convert the equation of a line from one form to another, and model and solve real-life problems using a linear equation. In Lesson 7.1, Slope-Intercept Form, we will be looking at one of the ways to describe a straight line graph. You will identify the slope and y-intercept of a straight line graph, determine a linear equation using the slope and the y-intercept, rewrite a linear relation in slope-intercept form, and graph equations and solve problems using equations that were in slope-intercept form. Recall that in Topic 6 we looked at what a linear relation was. A linear relation is any data that can be graphed and forms a straight line. There are many real-life situations that can be described using a linear relation. A few examples are water pressure that a diver feels depending on how deep they are, comparing degrees Celsius to degrees Fahrenheit, change in distance over time, which would show your average speed. In the graphs in this example, we have years played versus money earned in millions of dollars, probably for some professional sports players. And also, the square footage of a house affects the market price that it would sell for. There are many other examples. Try to think of at least 3 more that you could add to this list. One of the things that we are going to need in this section to write the equation of a line is the slope of the line. Now this is a review from Topic 6, Lesson 5 of the definition of slope. But remember, slope is the ratio of the vertical change to the horizontal change of a line or line segment. That is, the rise divided by the run. It describes the rate of change of the line. M is the letter that we use to represent slope, and M can be written as equal to rise over run, or the change in the y values divided by the change in the x values. If you're given 2 points on a line, you can write that as y2 minus y1 over x2 minus x1, where x1, y1 is the coordinates of the first point, and further to the right on the graph we have our second point, x2, y2. These are the values that we can use to calculate the slope. We will also need to use the y-intercept to write the equation of our lines. The y-intercept is the y-coordinate of the point where the line crosses the y-axis. It can also be described as the value of y when x is equal to 0. If 0, b is the point where the line crosses the y-axis, then b is the y-intercept. So if the y-intercept, say in this example, is 3, then we would say the y-intercept equals 3, or b is equal to 3. Just like we used m to represent the slope, b is the variable that represents the y-intercept. Alright, so let's look at how we can use the slope and the y-intercept to write an equation of a straight line. We call this equation the slope-intercept form. It is the equation of a non-vertical straight line in the form of y equals mx plus b, where m is the slope of the line and b is the y-intercept, and then they will be numbers in this equation. In example 1, we are given several equations of straight lines, and we want to identify the slope and the y-intercept of each line by just looking at the equations. Remember from our previous slide that the m value is the slope, and the y-intercept is the b value. The m value is the coefficient of the x variable in the equation, so it's the number written before x. And the y-intercept is the constant value, which is the number written by itself and in the equation. Let's look at the examples then to see if we can identify the slope and the y-intercept. In the first example, A, the number written in front of the x is 2. That would be the slope of our equation, or the m value would be equal to 2. That means that the rise of the graph is 2, and the run of the graph is actually 1. 2 can be written as a fraction of 2 over 1. So if we're looking to draw this graph, we can go up from a point 2 values and over to the right 1. The y-intercept then is the number that's written by itself, and that we call the b-value, or the constant in the equation. Because it's positive 3, our y-intercept is 3, and the point on the graph that would be where the line crosses the y-axis would be at 0, 3. In example B, the number written in front of the x value is again 2, so our slope is equal to 2, or 2 over 1 if you want to look at rise over run. And our b value, or our y-intercept, is going to be at negative 5 because we have minus 5 in our equation. That means that the y-intercept is at the point 0, negative 5. It's important that you use the sign that goes in front of this constant as either the positive or negative for the value. In example C, it appears that there is no number in front of the x variable. However, we know that if there's no number written there, it's like saying there's a 1, because 1 times x still just equals x, and we don't need to write the 1 there. So in example C, our slope is 1, or 1 over 1, if we're looking at rise over run. And our y-intercept is again going to be negative because we have minus 2 on the end. So our y-intercept is at negative 2, or 0, negative 2 is the coordinates of the point. In example D, we have y equals x. Again, when there's no number written in front of the x, that still means there's a 1 there. So our slope is still 1, or 1 over 1 for rise over run. And it looks like there's no number written behind the x either. Well, if there's no number written behind the x, what number would you add or subtract to the equation to not actually change the equation? That number would be 0. So be careful, there's still a y-intercept, and that would be at y equals 0, or the coordinates 0, 0. In example E, the number written in front of the x value is a fraction, so our slope is negative 2 over 3. And we bring the negative just to the top number of the fraction. That means our rise is negative 2, and our run is positive 3 on this line. Our b value, which is our y-intercept, is then positive 5, so the coordinates of the y-intercept are at 0, 5. In the last example here, F, we have negative x, which we say is negative 1x, so our slope is going to be negative 1 over positive 1 for rise over run, and our b value, or our y-intercept, is equal to positive 1, so the slope, or the coordinates of the y-intercept are at 0, 1. You can also refer to page 342 of the McGraw-Hill-Ryerson textbook for examples of slope and y-intercept and identifying them from the equations. I also just want to point out that all of these equations are in the form of y equals. So when you're trying to identify the slope and the y-intercept from the equations, make sure they're in y equals form. Example 2 looks at how the slope-intercept form of a line actually relates to the graph of the line. So we're given a graph and we're going to write the equation of the line in slope-intercept form. The first thing you want to do when you're looking at the graph is to find the y-intercept of the graph. So that is, where does the line cross the y-axis? So we have our line here, this red line, and we go until we find where it crosses the y-axis. That's your up and down vertical axis. And it looks like it crosses the axis at the point 0, 2. So we can write our b value, or our y-intercept, as positive 2. Next, we look for the next point on the line so that we can count what the slope of the line is. So from the y-intercept, let's go down to the right of the graph again until we get to an exact point. And that point happens to be the x-intercept, which is at 3, 0. So for our slope, if we look at the rise over run form of the slope. Let's first count what the rise is. So from the first point to the second point, how far do we have to go up or down? Well, we have to go down 2 values before we can start going over. So our rise is going to be -2. Then from there, we count to the right until we get to our next point. So we go 1, 2, 3 to the right. That means our run is +3. And therefore our slope is -2/3. So if we look at writing our equation now of this line in y equals mx plus b form, we sub the m value and the b value into the equation, and x and y stay as variables. So the m was -2/3, and then we put the x behind it, and then +2 for the y-intercept. Now you can check your answer or your equation by graphing your equation into your graphing calculator and seeing if it looks like the original graph in the question. So here are the steps of how to graph a line on your TI-83 or 84 Plus graphing calculator. You can also see a specific tutorial video of how to do this on your calculator. Step 1 is to press the y equals button. This button is found on the top left of your calculator just under the screen. To type your equation into the y equals menu, make sure your flashing cursor is beside the y1 equals spot. Then when you type in your equation, you need to type in the fraction in brackets. So you're going to type in bracket, then press the negative button, not the subtraction button, 2, and then divided by 3, and then close the brackets. That's your fraction for your slope. Your x button is right below the mode button, so press that for x, and then +2. You can then press the graph button, which is on the top right of your calculator, just below your screen. If you can't see your graph, you will need to go and adjust the window settings. However, if your window settings were already set to the standard window settings, then you will be able to see it. If you compare the graph on your screen to the graph in the question on the previous slide, they should look the same. For a little bit more practice on this slope and y-intercept and writing the equation of a line, we are going to look at the Your Turn question on page 344 in the textbook. What are the slope and y-intercept of the line shown in the graph? So the first thing you want to look for is the y-intercept, where the graph crosses the y-axis, which is at -1 on the y-axis. So your b value, or y-intercept, is at -1. To find the slope next, go from that point on the graph to the next coordinate that has exact values. So if we go to the right on the graph, and we go until we find a value that has an exact point on the line, and that would be at this point right here. From there, we're going to count the slope. From this point, we're going to go up 1, 2, 3, so that would be the rise, and then to the right, 1, 2, 3, 4. So our slope, if we look at rise over run, m is equal to, goes up 3 and to the right 4. So 3/4 is our slope. Then when we write that in the y equals mx plus b form, we just sub in those numbers. So y is equal to 3/4x minus 1. And that's the equation of our line. You can graph this equation on your calculator like we did on the previous slide with those steps, and check that the line on your calculator looks the same as the line in the question. Please see part 2 of this tutorial video for explanations of the rest of the examples.